good morning to one and all. So myself Muhammad Sheikh Rafi, and I am working as assistant professor in Aditya Pharmacy College. So today I am going to discuss the topic that is about antibiotics. So when coming to the definition of antibiotics, so an antibiotic or an antibiotic substance is a substance produced by the microorganism which have the capacity of killing or inhibiting the growth of a microorganism. Okay. So when coming to the classification of antibiotics, so there are various classes in the antibiotics. In that the first one is a beta-lactam antibiotics. Okay, the first one is beta-lactam antibiotics. In the beta-lactam antibiotics, there are various classes. Those are penicillins, cephalosporins, monobactams, and carbapenems. So why it is called a beta-lactam means the beta-lactam antibiotics, it contains a 4-membered beta-lactam ring. Okay, so that's why they are called a beta-lactam antibiotics. And the next one is beta-lactamase inhibitors. So beta-lactamase inhibitors means the microorganism, it produces lactamase, an enzyme which causes the breakdown of beta-lactam ring. Okay, to inhibit its growth, to inhibit the breakdown of the beta-lactam ring, they are using beta-lactamase inhibitor. We are going to inhibit the enzyme beta-lactamase. Okay, so the enzyme beta-lactamase, it causes the breakdown of the beta-lactam ring. So those are clavulanic acid, sulbactam, and the tazobactam. And the next one is tetracyclines. As the name itself, it contains 4 cyclic rings. That's why they are called tetracyclines. So examples are oxytetracycline and doxycycline. Okay, next the fourth class is nitrobenzene derivatives. Means these are the agents which contains a nitrobenzene structure. Okay, at the para position it contains a nitro group. Example, that is chloramphenicol. So the fifth one is aminoglycosides like streptomycin, gentamicin, amikacin, and neomycin. These are some of the examples of the aminoglycosidal antibiotics. So when coming to the next class, they are macrolide antibiotics. So the macrolide antibiotics, they are very huge in their structure and they are high molecular weight substances. So that's why they are called macrolide antibiotics. Examples are erythromycin, roxithromycin, clarithromycin, and the azithromycin. These are the high molecular weight structure. That's why they are called a macrolide antibiotics. So coming to the next class, lincosamide antibiotics like lincomycin and clindamycin, and the polypeptide antibiotics like polymyxin B, colistin, bacitracin, and tyrothirin. Okay, so this is a brief classification of antibiotics. So when coming to the history or the introduction of antibiotic, the first of all the antibacterial agents which inhibit the bacterial cell wall synthesis. Okay, so in that the first of all they are discovered by Alexander Fleming from fungal colony at 1928. First of all, it is discovered by Alexander Fleming at 1928. So and the next it's shown to be a non-toxic and antibacterial, and it is isolated. Okay, the antibiotic, first of all, it is isolated and purified by Fleury and Chain at 1938. Okay, Alexander Fleming, he has discovered the antibiotic, that is at 1928, but it is not isolated and purified. So in 1938, Fleury and Chain, they are isolated and purify the antibiotic. Okay, next in the next series, it is successfully synthesized. Okay, in synthetic manner, it is synthesized at 1941. So actually the antibiotics which is obtained through the these microorganisms, it is very in less amounts. So to increase the amount, we have to go for a synthetic methods. So in 1941, synthetic methods are introduced to synthesize the antibiotics. Okay, so to produce by the large scale of fermentation at 19 1944. So with the help of fermentation methods at 1944 they are produced the antibiotics in large scale. The next one, the structure established by X-ray crystallography in 1945. Okay, so we all know that X-ray crystallography, it is an excellent method for the identification of a skeletal structure of the molecules. So in 1945, with the help of X-ray crystallography, they identify the structure of the antibiotic. Okay, so in the next series, the full synthesis that is developed by Sheehan at 1957. Okay, the synthetic procedures are completely understand and it is fully synthesized. The antibiotic that is fully synthesized by Sheehan in 1957. And isolation of 6 APA by Beekham's at 1958 and 16. So the 6 APA means 6 amino penicillinic acid. It is by Beekham's at 1958 and the 60. So that is development of semi-synthetic penicillins. Okay, the discovery of clavulanic acid and beta-lactamase inhibitors. So after that, the discovery of clavulanic acid and the beta-lactamase are identified. Now this is the classification of penicillin. So we all know that in the classification of antibiotics, there are different antibiotics are there like penicillins, macrolide antibiotics and beta-lactamase inhibitors, aminoglycoside inhibitors, various antibiotics are there. In that first we are going to discuss about the penicillins. Okay, so this is the classification of penicillins. So penicillins are actually they are acid sensitive, means whenever it is reaches to the stomach acid, they are easily degraded. So to avoid this problem, they are synthesizing an acid resistant penicillins. Okay, this is acid resistance alternative to penicillin G. Okay, that is phenoxymethyl penicillin, that is called penicillin V. So penicillin G, it is acid sensitive penicillin. So to avoid this, they are preparing the phenoxymethyl penicillin, that is called a penicillin V, that is acid resistant. So next one is penicillinase resistant penicillins, that is methicillin and cloxacillin. So we all know that penicillinase, it is an enzyme that is secreted by the bacteria and it will cause the breakdown of penicillin, the lactam ring which is present in the penicillin, and it causes the inactivation of the penicillin. So to avoid this problem, the penicillinase, we are going to prepare a penicillinase resistant penicillins, means even though the bacteria it synthesizes the penicillinase, these drugs like methicillin and cloxacillin, they are still active in their function. So because they are penicillinase resistant. Okay, next extended spectrum penicillins. So in the class of extended spectrum penicillins, there are 3 categories are there: the aminopenicillins, carboxypenicillins and uridopenicillins. So in aminopenicillins, the drugs are ampicillin, becampicillin and amoxicillin. So in carboxypenicillins, that is carbanicillin and ticaricillin. In uridopenicillins, that is piperacillin and mejaclocillin. Okay, the last one is beta-lactamase inhibitors like clavulanic acid, sulbactam and tazobactam. So we all know that beta-lactamase, it is an enzyme that is secreted by the microorganism which causes the inactivation of the antibiotics. Okay, so we are going to introduce a new drug, that is beta-lactamase inhibitors. Okay, so this is the general structure of a penicillins. It contains a 5-membered thiazole ring. So this is the, so according to the R, a heterocyclic nomenclature, here the sulfur means it is called thia. Okay, sulfur means S means thia according to the heterocyclic nomenclature, and nitrogen, that is aja, and this one is called thiaja, and this is the 5-membered ring. So according to this heterocyclic nomenclature, the 5-membered ring that is called ol. Okay, the 5-membered ring that is called ol. So this is S thia, N aja and 5-membered ring ol. So thiazole, this one is the thiazole ring, and this is the lactam ring, the 4-membered ring which contains a ketonic functional group, that, and it is in unsaturated, and this one is a saturated molecule, so that's why it is a lactone ring. So this is the penicillin, mainly it contains a thiazole ring and a 4-membered lactone molecule. Okay, so here we are introducing an R. So R means we can replace these with different functional groups, like for example in case of ampicillin, in the case of ampicillin, at the place of R we are introducing this amino acid, okay, the amide functional group, okay, and in the case of amoxicillin we are going to introduce a phenoxy molecule, okay, phenoxy molecule, and in the place of R, if you are replacing with this aromatic amide and the amine functional group, it is called silacillin, okay. So similarly for cloxacillin, we are introducing at the place of R, we are introducing oxazole ring, okay. So this is according to the heterocyclic nomenclature. Oxygen means we are going to write oxa, and nitrogen is aja, and the 5-membered ring that is called ol. So the structure of this name is oxazole. So we are going to introduce an oxazole ring at the R position, then we got cloxacillin, okay. So if you are introducing a sodium ion for increasing its solubility, so it is called a cloxacillin sodium. Next one, methicillin sodium. So here we are going to introduce two methoxy groups to an aromatic ring. If you are replacing this structure at the R position, we are getting the methicillin sodium, okay. So this is a brief classification of antibiotics. So this is the position of the R, and this is the called numbering. So for nitrogen, according to heterocyclic nomenclature, so actually the penicillins, they are having two types of nomenclature, the IUPAC nomenclature and USP nomenclature. So according to the USP nomenclature, United State of Pharmacopoeia, for nitrogen we are giving a first numbering, and this one is second, for carbon third, sulfur is a 4, and this one is 5, okay, and this one is 6 and 7. This is the numbering of the molecule. So at penicillin G, in the place of R, we are attaching a benzyl side chain. This one is the benzene ring, and this is the alkyl functional group. It is called a benzyl. At the R place, we are going to introduce an benzyl functional group. Then it is called penicillin G or benzyl penicillins. But the penicillin G, the benzyl penicillin, it is acid sensitive. The next one is phenoxymethylpenicillin or the penicillin V, phenoxymethylpenicillin or the penicillin V. So in that we are going to introduce a methoxy functional group. This is the methyl group and the oxygen, methoxy functional group with an aromatic ring, that is penicillin V. Next one, methicillin means 2,6 dimethylphenylpenicillin. Look at here, there are two methoxy groups are there. At second position is one methoxy group, and at sixth position is another methoxy group. For example, this one is first number, second, third, fourth, 5 and sixth position. At second and sixth position, two methoxy groups are there. So that's why it is called 2,6 dimethylphenylpenicillin. This one is the phenyl ring. Phenyl penicillins, that is called methicillin. Okay, similarly, the nafcicillin, that is 2-ethoxy 1-naphthyl penicillins. This is the ethoxy functional group. Okay, and this ring, that is called naphthalene. Okay, so two aromatic benzene rings are adjacent to each other, so that is called a naphthalene, and this one is the phenoxy group. The naphthalene, phenoxy, 2-methoxy naphthalene, that is called nafcicillin. And this one is oxacillin. So oxacillin means 5-methyl 3-phenyl 4-isoxazole penicillins. This is the 5-methyl. This is the first position, 5-methyl. Okay. So according to the heterocyclic nomenclature, we are giving the first number to oxygen and second number for nitrogen, and the carbon is third. Okay, and this one is 4, and this is the fifth position. Okay, at fifth position methyl group is there, so 5 methyl and 3 phenyl. At third position phenyl group is there, this is the phenyl group. Okay, so 3 phenyl and 4 isoxazolyl. At the fourth position, this one is isoxazole. If the two heteroatoms are adjacent to each other, that is called, we are indicating with iso. So iso, and this oxygen is oxa and nitrogen is aja. Isoxazole, isoxazole and the penicillins. Okay, so at this structure, in this place, we are attaching penicillin. We are going to attach the penicillin. Okay, now this one is cloxacillin and dicloxacillin, ampicillin. So there are various structures of that. Next one is amoxicillin. At the amoxicillin, the D alpha amino P parahydroxybenzyl penicillin. So this is the D amino parahydroxy, and this is the para position hydroxy functional group is there, parahydroxy, and this one is benzyl penicillins. And next one is cyclacillin. At cyclacillin, we are going to introduce a cyclohexane molecule. So we are going to introduce a cyclohexane, that's why it is called 1-amino cyclohexyl penicillin. At the first position, we are introducing an amine functional group, 1-amino cyclohexyl penicillin. Next, carbanicillin, the alpha carboxybenzyl penicillins. This is the alpha position and carboxyl functional group, COOH. This is the COOH, a carboxylic functional groups. So next one, ticaricillin, at alpha carboxy 3-thionyl penicillins. Okay, alpha carboxy 3-thionyl. This is called thiophene. Okay, a 5-membered ring with the presence of a sulfur atom, that is called thiophene, but according to heterocyclic nomenclature, it is called thioenyl. Okay, because it is contain an unsaturation double bond, that is it one thioenyl. And like that, piperacillin. So why it is called a piperacillin means it contains a piperazine ring in the molecule. It is containing a piperazine ring, that's why it is called piperacillin. And mejaclocillin. So this is the ring. According to this ring structure, they are calling a mejaclocillin. So this is the a brief classification of penicillins. Okay. So coming to the mechanism of action. So penicillins inhibit the bacterial enzyme called transpeptidase. Okay. So remember this point. The penicillins, they are mainly act by inhibiting the actions of transpeptidase. Okay. So which involved in the synthesis of bacterial cell wall. So transpeptidase, it is an enzyme that is mainly involved in the synthesis of bacterial cell wall. Okay. So the normal human cells, they are not containing a cell wall, but bacteria, it contains a cell wall as a protecting membrane. So the beta-lactam ring involved in the mechanism of inhibition. So here in the penicillins, the beta-lactam ring, that is mainly involved in the inhibition of the transpeptidase. Okay. So penicillins becomes covalently linked. Okay, here the penicillin is covalently linked to the enzymes active sites, leading to the irreversible inhibition. So look at here, it is irreversible inhibition. Reversible inhibition means whenever the drug molecule it binds to the receptor or an enzyme, after some time it will leave that receptor or it is completely metabolized. But in case of irreversible, once the drug it will bind to the receptor or at an enzyme, it will not be metabolized until the drug it get completely destroyed, or the receptor it get completely destroyed, it will not leave. That is called reversible. So the main theme in the mechanism, that is the transpeptidase, it is an enzyme that is essential for the cell wall synthesis. Okay. Now in the case of penicillins, the penicillins, in that the beta-lactam ring, the 4-member beta-lactam ring, that will covalently bind to the transpeptidase enzyme and it will get inactivate the transpeptidase enzyme. So whenever the penicillin it inactivate the transpeptidase, then what happened? The cell wall synthesis get inhibited. So which leads to the bursting of the bacterial cell wall. So look at here. So this is the 5-member lactone ring. This one is the 5-member lactone ring. So in that ketonic functional group is there, RCO. So we all know that oxygen is highly electronegative. So what happened? So there are two double bonds are there. So in that one is a pi bond and one is the sigma bond. So the pi bonded electrons, they are shifted to the oxygen. So oxygen got the negative charge because the electron density on the oxygen get increases. Now here the carbon, it got the positive charge. So carbocation is produced here. Okay. Now this one is the enzyme, that is transpeptidase, a bacterial enzyme, transpeptidase. So the enzyme, it contains nucleophiles. The nucleophiles means they are electron rich, means they are able to donate the electrons and they can form a covalent bonds. So now the nucleus, it donates electrons to the electron deficient carbocation and form a covalent bond. So look at here enzyme, nucleus and the carbon, it forms a covalent bond. This one is the covalent bond. Now the oxygen, it is in electronegative form, okay, O minus. So these electrons, they again moves back in between the carbon and oxygen. Okay, so what happened? The electron density on the carbon get increases. To neutralize this charge, the bond between the carbon and nitrogen get break down. Okay, this is the main point. So to neutralize the carbon, electronegativity of the carbon, the bond between the carbon and nitrogen, it will get breakdown. So here chain will get opened. The 4-membered lactone ring, it will get opened and a covalent bond produces between the 4-membered lactone ring and the lactamase, the transpeptidase enzyme. Okay. So thereby it causes the inactivation of the transpeptidase. So but we know that the transpeptidase, it is an essential enzyme for the maintenance of the rigidity of the cell wall. Okay, thank you.